In this video, we are going to look at application of first order differential equation. For purpose of understanding, I'll encourage you to check the description of the check ways in which we can solve differential equation, which is the first order differential equation, whether homogeneous, non-homogeneous, separable, or separable. So the first application we're going to talk about is orthogonal trajectories. Now, suppose that we have a family of curve given by f as a function of x, y, and c is equal to 0. And then we have another family of curves given by a g is equal to x, y, and k is equal to 0, such that at any intersection of the curves, which is the intersection of this and this, the tangent of the curves are perpendicular. So therefore, are two families of curves that always intersect perpendicularly. Now let's look at something. Another example is the family of circles represented by, so when you take the family of circles represented by x squared plus y squared is equal to c, with center at this origin, and the family y is equal to ks of straight lines through the origin, are orthogonal trajectories of each other since they intersect perpendicular. Now, so for understanding purposes, I've taken some examples that this application for us to solve. But solving the orthogonal trajectories of any question has 4 steps. And the third step is you learning how to solve the differential equation. That's why we are applying it here. The first order differential equation, how to solve, whether separable, homogeneous, non-homogeneous, or non-separable. So then let's get into it. So let's take the first example that we're going to look at. So with the first example, they are asking us to find the orthogonal trajectories of family of straight lines through the origin. Well, they didn't give us the equation, but I think from the previous thing I said, we can know that the equation will be what? Y is equal to ks. I said it when I was explaining the meaning of orthogonal trajectories. So now I told you that there are 4 steps involved when solving the orthogonal trajectories. So you're going to take the first step, which is step 1. Step 1. So for step 1, you know, the family of straight lines through the origin is given by this, which is, let's do this as equation 1. So step 1 is to differentiate implicitly with respect to x. So when we differentiate implicitly, so differentiating implicitly, you know that you're going to get that when you differentiate, you're going to get dy over dx. There will be 1 here, but we don't bring it, which is equal to k with respect to x. So this will be 1. And this, when you do this also will be 1, which will be 1 dy dx is equal to k. Then the second step that you're going to take, this is step 2, is to eliminate the parameter k from the equation. So this is step 1. So we are going to eliminate the k from this step 1. How are you going to do it? So what you are going to do is that you are going to make k the subject from equation 1. So you make k the subject from equation 1. So when you make k the subject from equation 1, you know that making it the subject, you are going to get that k is equal to what? Y over x. Then we will substitute it. So you are going to get dy dx is equal to y over x. Let's go to the third step. Step 3. So for the third step, what to do now is that we will replace dy over dx by -1 over dy over dx. We are going to replace -1 over dy over dx with, so we are replacing dy over dx with -1 over dy over dx. And when you do that correctly, you know that for step 3, you are going to get our dy over dx is equal to negative x over y. After replacing this, so here with step 2, you are going to replace negative 1 over dy over dx. So when you do that, you're going to get our step 3 to have this. Now, our step 4 is whereby we apply the first ways in solving first order differential equation. So after getting this, we are supposed to find how can we solve this. So we're solving this using any ways. The answer that we're going to get is for step 4, which is solving the differential equation. In this case, first order differential equation. So when you solve it correctly, you're going to get x squared plus y squared is equal to c. Now, the orthogonal trajectories of family of lines, which is straight lines through the origin, is given by, which is y is equal to kx. Note that this equation is the family of circles with the center at the origin, right? So this also is another one, and this another one. So at the end, we find the family of this one. So they say what? We should find the orthogonal trajectories of families of what? Of family of straight lines through what? The origin. This is the first one, and its family. So that's very simple. Using the 4 steps, you can find any orthogonal trajectories of family of what? Curves, straight lines. Let's move on to the second example. For the second example, we are supposed to find the orthogonal trajectories of what? The family, which is cx squared minus y squared is equal to 1. So now, what will be the first step to do? The first step to do is what? To differentiate implicitly. So step 1, let's put that in our head. So we're going to differentiate this implicitly. We're going to get what? Pause the video and give me the answer. So let's see. We're going to get 2cx minus, and this will be what? 2y dy over what? Dx is equal to what? 0. I hope you had that right. Now we have the step 2. What will be step 2? For step 2, we need to eliminate the parameter c. Now we have the first one was k, but now the parameter has changed to c, which is a constant. So then we need to make c the subject from this equation. So then making c the subject, you're going to get that c will be equal to what? 1 plus y squared all over x squared. So then we are going to substitute this to where the c is. And when you do the substitution into the step 1, the answer you're going to get is dy over dx is equal to 1 plus y squared all over what? Xy, which is step what? 2. Now for step 3, I hope you remember step 3. We are going to replace the dy over dx with negative 1 over dy over dx. And when you do the replacement, what you're going to get is you're going to get that dy over dx is equal to negative xy all over 1 plus y squared. And step 4, which is the application for this, is we differentiating it using either ways of solving the first order differential equation. So when you see this, how can we solve this? We can use the method of what? Separation of variables. Method of what? Separation of what? Variables. Separable form, right? So we can use method of separation of variables. So when you use that, we're going to have that our equation will be, we find it, you first try separating the x to one side, y to one side, and then you find the integral of both sides. So when you separate, you are going to get that it's very simple to separate. You're going to get 1 plus y squared all over what? Y dy is equal to the integral of what? Negative x dx. Then you integrate this, then you integrate this. When you integrate it, you can therefore simplify this as what? The integral of bracket open, which is 1 over y plus what? Y dy is equal to negative the integral of x dx. Then when you do that correctly, you're going to get that our ln y plus bracket open y squared over what? 2 is equal to negative x squared over 2 plus what? A constant c1. So therefore, when you simplify it, you're going to get 2 ln y plus y squared plus x squared is equal to what? C1. So therefore, this will be the what? The orthogonal trajectory of this, which is also their family of what? Trajectories. Thank you very much. Now let's move on to the last one, which is also very interesting to solve using the 4 steps. So for the last one, they say we should what? Find the orthogonal trajectories of the family, which is y squared is equal to cx cubed, right? So now you can pause the video and try it and kindly send it on the the comment section. So let's go. Now we have that step 1. We should what? Solve this what? Implicitly. So when you solve this implicitly, what are you going to get? You're going to get that. You're going to get dy over dx is equal to 3cx squared all over 2y. You're going to get 2y. I hope you understood this, because you're going to get 2 over here. Implicit, that will be 2y dy over dx is equal to 3cs squared. And then you make dy dx subject. Then you're going to. Now step 2. With step 2, we are supposed to eliminate the parameter, which is c. So therefore, we make c the subject from this. And when we make c the subject, you're going to get a c is equal to what? Y squared over what? S cubed, right? Then we do substitution to step 1. And the substitution, after the substitution, you're going to get our answer to be dy over dx is equal to 3y over 2x, which also is equal to a function of what? X and y, right? Then our step 3. I love step 3 very much. That's replacing the dy over dx with what? Negative 1 over dy over what? X. Then when you do the substitution into it, you're going to get that our answer will be dy over dx is equal to negative 2x over 3y. That's very simple. Then we move on to step 4. So with step 4, what you do now is that you're going to solve the first order differential equation. What is this? And with this, you know that we can use separable. As very simple as that. So for separable, this will go here, this will go here. So you're going to get the integral of what? 3y dy is equal to what? Negative the integral of 2x dx. And when you do that correctly, you're going to get 3 over 2 y squared plus x squared is equal to what? C1. And this becomes the family of the orthogonal trajectory of the family for y squared is equal to cx cubed. So this is how